All right, so if you guys are following up the first review video, you guys know we're working on station number 3. If you're following along from the stations in class, or if you're just working with the problems at home, this would be problem number 3. Now, we had just found that angle 3 was 150 because angle 2 was 50, and these are a linear pair. They must be supplementary. They must add up to one another. Let's look at finding the remainder of our angles here. The remainders of our angles are very, very easy to work with. Now, the same property we used earlier to find number 2 is going to be the same property we used to find angle 6 and angle 7. Notice, sorry for that interruption, we're going to be using the same property as earlier that defined angle 6 and angle 7 as we did to find angle 2. You'll notice in this triangle, angle DWC, we know 2 of the angles. We have 25 and 30. And as we know by the triangle sum theorem, all 3 of these angles need to add up to 180. I have 2 of them, 25 plus 130 plus x equals 180. We simplify. This would be what, 155 plus x equals 180. Subtract 155 from both sides, and we get x equals 25. So we have another isosceles triangle inside of our rectangle. So we have angle 7 now is 25. And it also follows logically that angle 5 would also be 25. It's the exact same triangle. These are 2 congruent triangles. So angle 5 is also going to be 25. And I'm sure that you guys see again some other similar problems here. Angle A and angle C. Notice they're both equal to 90. This portion is 65, 25, so angle 6 would also have to be 65. Both of these angles need to add up to 90. I'll write that out just so you guys at home can see that. Because angle C is 90 degrees, I know that a portion of it is 25 plus some other angle must equal 90. Therefore, I'll put a little x in here. X must equal 65. So we have found all of our angles in a rectangle. And as you guys start to see, as you fill this in, you'll start to see some patterns existing. This will be true for most, if not all, rectangles. You know, it's a 25, 65, 65, 25, 25, 65, 65, 25. Oh, not 26, 25. That pattern will exist. And you'll notice here a common misconception was that the intersection of the diagonals is perpendicular. That will not be the case for a rectangle. There's no rules about the intersection of the diagonals, at least angle-wise. We do know that they split each other in half, but beyond that, we know nothing about the angles of their intersection. So make sure you pause this video if you need a little more time to copy this down, and then we'll be looking at example number 4. We'll be looking at example number 4. All right, let's take a look at station number 4, or problem number 4 if you're following along at home. First thing we want to look at again, notice that this is a rhombus. If you are following along at home, get out your notes and flip to the properties of a rhombus. There are a few. The main one in this definition is that all of the sides are the same. This will be very helpful for today. We know that SX is 7 2/10. That means all the sides have to be 7 2/10. This is why it's so important. One of our keys to success is knowing the properties. If you do not know the properties, you will fail. You cannot make this stuff up. You cannot guess that this stuff is very difficult to do that. Make sure you have thorough notes. And if you don't remember the properties of a rhombus, watch my video on the definition and properties of a rhombus. I'll see if I can make that little box thing pop up where I'll link you to my other video. I haven't done that yet. So we have all the sides. Pretty easy, right? So we know ST is 7.2. We have TW is 7.2. And XW is also 7.2. Now, there are some other special properties in a rhombus. I'm going to erase those sides. We got that down. The other nice property in a rhombus is that the diagonals bisect each other. Therefore, these 2 lengths will be the same. Now, the diagonals themselves will not be the same. The length of the whole diagonal will not be the same, but they are split in half. So it should be pretty easy. Is if we know that, SJ is 5. Let me change the color here. SJ is 5. It's pretty easy to figure out what JW is going to be. JW will also be 5. Therefore, the length of SW is 10, using that segment addition postulate. I had a lot of people on the other side, in the other classes, say that TJ was also going to be 5. This is wrong. We know that the whole length of XT is 6. So it'd be pretty easy to follow again, since these are bisected, that both these pieces will be the same, 3 and 3. Lengths in a rhombus as well as a rectangle should be pretty easy for us. Lengths in a square, even easier. Just make sure we are following our properties and you know which shape you are working with. We could not answer this question if we did not know it was a rhombus. So if you need a second, pause the video, record down these answers, make sure you have the properties written down for the assessment. All right, so now we just looked at the lengths in a rhombus. Now we're going to be working with the angles in a rhombus. Angles in a rhombus. Now, this is not station number 5 if you're following along in class. This one is station number 6. This one is station number 6. Now, again, this one is relatively time consuming, but there's a few properties that make this very, very easy for us. I'm going to start with the one that most people knock right off the bat, is that the intersection of our diagonals, where point J is the intersection. Remember, our diagonals are in blue, are all going to be 90-degree angles. They intersect at a perpendicular angle, 90, 90, 90. Very, very easy. The easiest one to knock out. So I know that angle 3 is 90 degrees, and angle 4 is also 90 degrees. Really, really easy. Does not matter the size of your rhombus. This will always be true for a rhombus. The intersection of those will always be 90. So let's move forward. Now, what I like to do first is I like to try and find the large interior angles first. Because this is a parallelogram, it follows some very, very simple rules. Angle 5 would probably be the easiest one to find that would help us with angle X. Angle 5 is also equal to 62. We know that the diagonals, again in blue, of a rhombus bisect the angle. So both of these portions need to be the same. Both of those need to be the same. If one half of it is 62, the other half would also be 62. This is only true for squares and rhombuses. Only true for squares and rhombuses. That's why we couldn't use it in the rectangle example we just wrapped up in. So we have angle 5 is 62 degrees. This will make it very easy for us to find angle X. Angle X is just these two pieces. So it would be 62 plus 62. Therefore, angle X equals 124 degrees. I'll fill it in. Try and find those big angles first. If we can find our big angles first, it's pretty easy to apply the properties of a rhombus. 124 degrees. I'll write that off to the side as well so you guys can see it visually next to that problem. Now, once we know what one of the large angles is, it's very easy to find the rest. A rhombus is a parallelogram, so we know that the opposite angles have to be the same. Angle T is also 124. And again, why it's so helpful that we have all of our property sheets out in front of us. We know this is a rhombus. If we have a property sheet, we can apply all the properties of a rhombus. Now let's try and find angle S and angle W. Because a rhombus is a parallelogram, our consecutive angles are supplementary. So I know angle X plus the measure, we can just put in plus the measure of angle S is going to be 180. We know both these have to add up to 180. Angle plus angle S equals 180. Right? I know angle X is 124. I just need to solve equals 180. Subtract 124 from both sides. Pretty easy math. And we get angle S equals, what is that going to be, 56? Is that going to be 56? Okay. 56 degrees. All because these two are supplementary. So I'll also fill in that angle W is 56. Remember, opposites are always the same in our parallelograms. And we know that a rhombus is a parallelogram. So now we have all of our big angles. It makes our work much, much easier. Angle S and angle W are 56. Angle X and angle T are 124. So each one of these diagonals splits our angle in half. Therefore, these angles are both going to be 124 divided by 2. This would be 62 and 62. Pretty easy to follow. These angles up here are just going to be 56 divided by 2, which would be 28 if I'm not mistaken. 28, 28. These angles here will also be 56 divided by 2, so 28, 28. Again, we see a pattern. At the intersection of each one of these diagonals is the same. Same thing at the opposite angles. Same thing with angle X. Same thing as angle T. So let's fill in our answers. I know it's a little cluttered in here, so I'll do my best to clean it up and get our answers really easy for us to follow. Each one of these angles is 28, 28, 28, 28. Each one of these angles is 62, 62, and 62. So angle 1 is 28. Angle 2 is 62. Angle 7 is 28. Angle 6 is 28, and angle 7 is also going to be 28. So we have all of our answers here, as well as written in these portions right here. So make sure as we're working through a rhombus, we know what our properties. If you do not know the properties, again, this problem gets incredibly difficult. So if you're having some trouble, pause the video, go back and watch my video on the properties of rhombuses. Maybe even level 1 example would also help with this one as well if you find this one relatively challenging. It's a good follow-up problem. So pause the video if you need to copy any of this down, and then we'll move on to station number 5. All right, for those of you who are following along at home, we are now looking at station number 5. Station number 5. Again, big thing here is we have a parallelogram. So if you have your notes out, why don't you turn to the page that contains our definition and properties of a parallelogram. We have a parallelogram. Now, I'm going to label in our answers, or our thing we were given, that CD is 10. It's already marked in there. DE is 5 3/10. I'm going to mark our quick answers quickly. Remember, opposite sides are congruent. CF is also 5.3. DC is going to be the same as FE. Opposite sides, or CD, this portion right here. No. Yeah, oh, sorry, yes. I said CD is going to be the same thing as FE, which is going to be 10. Now, again, we have our exterior sides. The sides are very, very easy to do. Remember, opposites are congruent. Again, if you have your notes, very, very easy to do. Now let's look at the other portions they gave us. They gave us CE, which is this diagonal right here. Let me get my highlighter tool so we can highlight it. We're given that CE, this whole diagonal is 15. I'll write that down right next to it. This is 15. I'm also given that GF is 8. So let's use these lengths in our properties to find the missing portions. Now, I've already marked our sides. I'll mark those in for us. We know that, let's do our sides. CF, where's that? CF, 5.3. We also know that FE, which is down here, is 10. So let's find our other lengths. How can I find the length of DF? Yeah, go ahead. If those of you could not hear that at home, we were given that GF is 8. We also know that DG is going to be 8. These diagonals bisect each other. So that means the whole length DF is going to be 16. It also logically follows that CG, that our CG right here, is going to be, 7.5. Because each one of these pieces need to be the same. I'm just dividing 15 by 2. And then DG, oh, we already have that marked, awesome, is going to be 8. Now, to get the last example, example 7, please check out my next video, which will be labeled Review Exercises for Unit G number 3. Review G, Exercise 3. Make sure you check out that video for our last station. It'll be a quick one. Thanks for watching.